all of the mass of the atom, right? So, because the nucleus is really small compared to the atom itself, right? Because you got a tiny nucleus and then the electron cloud all around it, right? I think they compared it. What was the comparison? Like if you had like one person, and then that person represented the nucleus, and then the electron cloud would represent like I think it was like.
Well, if you have if the nucleus is the size of a tennis ball.
Yeah, nucleus is the size of a tennis ball.
Okay, then the atom would be the size of like Bryant-Denny Stadium.
Yeah. So that's kind of the comparison you should think about here. So as a result, since it has all the mass, it's super, super dense, right? Because it's this huge volume of atom condensed in this tiny little space called the nucleus.
So how do you fill it in?
How do you fill it in? So this nucleus is very tiny, yet contains relatively all the mass of the atom.
Okay, so the question is, how dense is first off, what does density mean? How tightly packed? How much does a small amount weigh?
Mm-hmm.
So just imagine you have a cubic centimeter box, just 1 centimeter by 1 centimeter by 1 centimeter box. And it's filled with nothing but nuclei, not the empty space, not the electrons, just nuclei somehow could all fit in this 1 little centimeter box. How much do you think that 1 cubic centimeter box would weigh? A lot. What's a lot?
More than me.
More than you. That is true. So give me some wild guesses.
1,000 pounds.
1,000 pounds. It's more than that.
1,000,000 pounds.
1,000,000 pounds. That's pretty wild, but it's more than that.
Oh, a trillion.
That's less than that.
1 billion.
Okay.
6 billion?
No, it's about 50 million metric tons. Now, metric ton is 1,000 kilograms or 2,200 pounds. So it's closing in on a billion. Okay, that 1 little cubic centimeter. The converse of that says that if you need to get enough nuclei to fill a cubic centimeter box, you have to have 50 million metric tons of material to fill that box of just nuclei. So what does that mean about the size of the nucleus?
It's small.
Pretty small.
It's very, very, very small. One other little tidbit here, I can't help myself.
Yeah, no. These are cool facts. I remember you talking about these earlier, but yeah.
That you can't pick up.
Yeah, exactly. that would be, nothing could pick it up, that's right. That's how dense it is. So in other words, all that mass is in there. Now Rutherford, first off, Rutherford did not do the experiment. Rutherford designed the experiment, then he made 2 underlings, Geiger of Geiger counter and Marsden, actually do it.
Oh, see, I didn't know that.
And they sat in a dark room, and they set up the gold foil, and they shot the alpha particles at it, and it had a fluorescent screen, just kind of like a TV screen. When the electrons hit it, it ends up glowing. Okay? So they would watch it, and they could see the particles hitting, and it would just be these like sparks going off on that fluorescent screen. Everything was going straight through. And by the way, Rutherford wasn't even looking for the nucleus. He was fascinated with radioactivity and alpha particles, and he wanted to see how alpha particles affected the gold and whatever, but most of them were going straight through it. But every few would be slightly deflected. And then some came bouncing straight back. Okay, he kind of just made that as a whim, hey guys. And so what they did for weeks, they just had to look through an eyepiece and stare in a dark room and count flashes. For weeks. In a dark room. And nothing happened. And then Rutherford said, hey, look, let's put a screen on the backside, see if anything's bouncing off. And again, for a week or so, nothing happened. So they're in there just staring at this for nothing. Then all of a sudden, bam, they see one flash back here. And somehow they calculated that it was 1 in 8,000. So I could just imagine them sitting there in that room. 1, 2, 3, 572, 573, 7,800, 7,999. Oh, there's one. 1, 2, 3. I'm not sure, but they didn't have any machines helping them. They were strictly looking at it. So, can you imagine how boring that would have been? But that's the way science got done. But they figured 1 in 8,000 actually hit the nucleus. That's how you know it's tiny. Because the majority went straight through, just by law of probability, because only 1 out of 8,000 hit it. And then the fact that it came straight back, Rutherford makes the statement, it was as if you fired a 15-inch shell. That's like off one of those Navy gun ships, you know, the big guns that they have that you see in movies, okay? 15-inch shell at a piece of tissue paper, toilet paper, and it came back and hit you, okay? He was fascinated by it, okay? It kind of reminds me of the Roadrunner and the Coyote. You know how everything backfires on the Coyote? It's kind of like that, you know, it just hits that and bounces back, okay? It took him months to figure out how that could be, but eventually came up with his model then that you have a tiny nucleus, positively charged. The ones that came close were the ones that were slightly deflected. The ones that hit it came straight back, okay?
This is making sense.
Yeah, so that's how he came up, but again, it was a lucky thing because he really wasn't trying to figure that out. He just kind of fell into it.
Especially with the model that he had. I mean, like we said, the model that he had, that he thought what the atom looked like, was the plum pudding model.
Right.
So he had no clue that it was actually just this really tiny, dense nucleus with this giant electron cloud. So he was, like he said, the experiment was not even to the point to try to figure out what the nucleus was. It just so happened to stumble upon it. And there's a lot of scientific experiments where they're not even going for what they end up discovering, but it just ends up happening that way because they find something that happened in their experiments that doesn't fit in with the hypothesis they made, and then they ask the question why. And so they set up another experiment to kind of look at that. So that's generally how
One
science
other thing, I can't help myself. The table that you're sitting at, if the theory of the atom is true, most of the atom is empty space, that means that table is mainly empty space. Okay? You are mainly empty space. Okay? Everything in matter is basically empty space. There's a classic 1980s sci-fi B movie called Buckaroo Banzai Across the Eighth Dimension.
I really want to see this movie.
Okay? It's got big actors. It's got Peter Weller in it. It's got Doc from Back to the Future in it. It's got the guy from Independence Day or Jurassic Park, Goldblum.
Yeah,
Goldblum.
Orlando.
Okay? It's got a bunch of famous actors in it, but it's a really cheesy movie. Okay? But Buckaroo Banzai is able to penetrate the inner space of matter and go through a mountain without, you know, and then come out on the other side with no hole in the mountain, you know? So
Sounds like-
that was the whole premise of the movie, the science fiction.
That
is
sounds
inner
like Ant-Man.
space. But
Yeah,
it turned
yeah,
out
Ant-Man.
that there was a whole life system going on inside that inner world. So just think, if each atom is its own solar system, and each electron is like a planet, and maybe there's a little microcosm of life, and that table could be its universe.
That's crazy.
That is crazy. Or just think of our solar system as being one big atom in some larger cosmic being. Maybe we're just part of God. Maybe that's what God is. I don't. I don't really believe that, but it's just something that's fun. Anyway, all right, I'm done. I promise.
It's all good. I mean, we basically got through what the notes that we have so far. So now we're gonna kind of go over 2 other experiments here. I don't know if we'll have time for both, but luckily, if I do have to send it home, this article is 1 page long, and it has big text, and it has a picture. So it will not take you very much time to go through that one. But we're gonna go over Miquelin's oil drop experiment here. So this is how he actually ended up discovering the charge of the electrons here. So you're gonna figure out, A, what that charge of the electron is. This is question 3 here. And then, I guess I had what did Miquelin's oil experiment find, which I've already spoiled. But just reading through, trying to figure out what the charge of the electron is and kind of how he did it. And I think it's pretty neat. We can kind of go over the 3rd question. I don't know if this article really expressly covers the 3rd question on there, but we can kind of, I think it kind of somewhat covers it. There you go. There you go. So yeah, just read through this and then try to answer that 3rd page in the research guide here. Feel free to talk among people if y'all are if you're confused about maybe some wording in the article. Ask me, ask a classmate, and do that. Also, don't worry about page 3 that much. Page 3 mainly covers how the process that Michelin had to in order to get the formula he needed for it. So if you're interested a lot in mathematics and deriving formulas, that page is for you. But honestly, that page printed out weird, so there's a lot of weird text in it. But that's kind of like the thought process he used in order to get to what he wanted to get. So you don't have to really worry about that page too much, but the rest of it is important information. Yeah. All right, we can quickly go through up to the number. I probably pull up the third page, just make it easier so you can see the questions, right? Yeah, because you already did page one, page two, right? So just scroll down on that one. Oh. You're good. Gotcha. Yeah, I just want to double check it because it's a lot easier to see the question and then be able to kind of look from there. Alright. Let's see. I have another article on it because it kind of explains. See if it has, because the article I was initially going to give you has a good explanation as to why he ended up using oil, which I think is neat. But I think I might have tossed it. I need to remember exactly. If I can find it. Is there it is. All right. That's, I had to refresh myself on that fun tidbit, but now I can share it with y'all. Want to make sure we can just talk about it for 135 here. Do y'all like 3 minutes? Should be able to find at least the first two questions, and we can briefly talk about the third question. Yeah, the last page is a picture too, so that's just that last page is just like what people use now to kind of simulate that experiment. So like you might see that in like college physics labs, but not in the physics that I took because I only took up the physics 2. But I'm assuming what other step right after physics 2 is you're gonna mess around with that. Yeah. The research guide questions. Oh, so that was fine because I only asked for the first 2 pages for the assignment because all you had to do was read that first article. I'll submit another assignment that says to submit 3 and 4 because that's what we're going to cover for today for the online. So yeah, don't unsubmit it. I only wanted was the first 2 of that. We're doing the second half today, so. All right. Do you think we got good answers for the first 2 questions on that? Pretty comfortable? What are y'all thinking? Thumbs up if we're good. See 1 thumbs up. Wow. All right, 2 thumbs up. No. All right. Yeah. Still take your time. I got a few seconds left. So, all right. I saw Taylor's thumb for a second there. Got a few minutes left. So just take your time on that. We'll talk about it at 140.
Here's your answer sheet, so you can finish test corrections. You can just finish test corrections. He's gonna be on, I think I said Sunday.
Yeah, I think I saw something as well.
Okay, so just, it's just a free response, all you gotta do is free response questions. You should be able to figure those out from what you have.
Oh, for Chadwick, so on the note, this is from the research guide.
Oh.
Yeah. So we're not getting to Chadwick today, because Chadwick's the other article.
Oh,
Chadwick's this one-page article. I'll post that online and so to make sure y'all get this. But yeah, like I said, it is quite literally one page, so it shouldn't be that much extra for y'all. You got it? Okay, so let's talk about it then. Actually, Carson,
I'm good.
you're good? You're just reading the fun process. It is actually a really neat experiment. I mean, so I don't blame you at all. So, let's replace these guys real quick. Boom. Okay. First question. I've already kind of spoiled it when we were talking about it. So what did Michelin's experiment find? Charge of an electron, right? So what was that charge? Yeah, Olivia? Negative? So there's a specific number to it, and there's a reason. So there's a specific number for it. Madeline?
1.5924 times 10 raised to negative 19.
Gotcha, right? So negative 1.5. I'm just saying 1.59 times 10 to the 19th. I think it was 10 to the 19th here. Coulombs, that's a measure for electricity. So we don't go over that really yet. But if that's just something, just in case you're confused about the word Coulomb, why there's a C there. More specifically, he found out that electrons were what of this number? Like if you have one electron, you're going to have this. If you have two electrons, you're going to have what? Like, so what would be the charge of two electrons here?
That times 2.
That times two, right? So he discovered that all electrons are essentially multiples of that number, right? Which is why we don't, when we're talking about the charge of an electron, we say, -1, -2 for two electrons, right? We don't say minus 1.59 times 10 to the 19th minus whatever twice that would be. I'm not going to do the math in my head because I don't think I can. We don't say that because it would be it would be miserable. So that's why we as scientists can be like, okay, we're going to say that this is just one charge of one electron, so -1, -2, -3. So the third question on there, this is more of a question. We would have gotten to this if I used the other article, but the article that I was going to use is a little longer, so I decided to just kind of give you a nicer article to read, give you less work to do at home. So the really cool thing about this is when he was initially doing this, he wanted to use water atoms or water molecules, but when he did y'all read the article right? And y'all saw what atomizing and what he kind of meant by that. So when he did the experiment, he had to make the basically he turned what he used the oil into aerosol spray essentially. So that's what he kind of referred to as atomizing, where he basically made it into a sprayable form where it was just really small particles.
Think like a perfume sprayer.
Yeah, like a perfume sprayer essentially. So what happened with water is water actually evaporated too quickly in his experiment for him to even read it. So because it evaporated way too quickly, so that's why he was just thinking about it. It's oh, well, what might not evaporate as well? Oil. We'll try some oil, and so that's why it's the Michelin oil drop experiment and not the Michelin water drop experiment, right? It's because he ended up using oil instead because it just made it stuck around longer, which means he could actually do the calculations based on the experiment. So that was just a cool tidbit on that question for you that, again, y'all would have gotten, but I needed to find some shorter articles so y'all weren't suffering at home. So we don't have really that much time left. There's not really any notes to fill in about Michelin oil drop. Because that was mentioned, I think it's like on page 2, where it mentions the electron for your notes. It kind of briefly mentions that Michelin discovered the charge of an electron. But it's just cool to kind of flesh that out. So we don't have much time, so I can't really go over James Chadwick, so I'll probably send the thing online for y'all, just to go over it. Again, 1 page. Not going to take too long. It's just kind of discovering what the nucleus is. And then from there, I think on Friday, besides some other initial things we're going to do, you're going to, well, 1, I got to assign all your elements, which ones you pick. And 2, with the information you've got from everything we've learned here and this article right here, what I want you to do is kind of to sketch a somewhat accurate model of your element that you get. So, like if you get chlorine or something, I just want you to sketch a model of what you would use for chlorine. So, again, it might seem daunting, but we've kind of gone over what a general structure looks like, where you know, like, Rutherford's model, again, is that dense nucleus with a bunch of electrons around it, right? So, basically, we just need to flesh out the nucleus, right? So, and that's all we really need to do here. So, it's just kind of, each element's going to have a different looking nucleus. So, just making sure that you represent that in your drawing, and then as well as the giant electron cloud is going to be really important. So, again, all of this was based on the stuff we just read. So, any questions on like stuff we just read, or the project, or anything there?
You said the project was due Tuesday, right?
It's due Tuesday, yeah. It is not due tomorrow. Any other questions on that? No? Have y'all messed with Flipgrid yet, or just you have? Okay,
I
cool.
did a lot last year.
Okay, gotcha. See, I was worried if I wasn't sure if y'all had messed with it or not. So, because that was the first time I experienced Flipgrid. It was like 2 days ago. So I was like messing around with it to see how exactly to set it up, and I think I've set it up well. So if y'all are familiar with it, then that's good. Also with it, like, feel free to be creative. Like, I named it Atomic Structure Shark Tank. Have y'all seen Shark Tank, the show? You've heard of it? Yeah, I mean, I want to essentially be like, you're a business and you're trying to present your atom to me, and you're trying to sell me on why your atom is cool. So, or why I want to buy your atom, right? So feel free to, be creative with it and do what you want with the project. It just needs the specific, like, all the project needs is just the information that I laid out in the instructions guide, right? If you put all that in there and then make it a creative way, you can make it like a infomercial, like if you want to be the next Billy Mays or ShamWow guy or Phil Swift, feel free to. But yeah.
Yeah, so I won't lose it.
You can talk about the power
So
of
next
chlorine.
will be Monday.
It's very fashionable, you guys should get it.
But yeah, I'll make sure to get your elements that you get by the end of the night. So
Okay, thank you.
you'll know what you're doing